Okay, so we're going to look at graphing rational functions. We're not going to use a calculator. So first thing we want to do here is we want to figure out what the vertical asymptote is. So remember from class, we took the denominator, we set it equal to 0, and then we solve for x. So we have a vertical asymptote at x equals 2. So we're going to go to x equals 2, and we're going to draw in our vertical asymptote. This is where it's going to split our function into 2 equal parts. Okay? Next thing we're going to do is I'm going to put this 2 right here. It's going to split it up. So going to the left of 2, we've got 1, 0, negative 1. Going to the right of 2, this is going to be the right side. This is going to be the left part. This is going to be the right part. So going to the right, we're going to have 3, 4, and 5. So plugging it in, let's start over here with 2. Well, 2 minus 2 is 0. And you cannot divide by 0. That's why we have a vertical asymptote right here. It does not exist. Okay, 1. So plugging 1 in, we got 4 divided by negative 1. Negative 4. 0. Plugging 0 in, we have 0 plus 3, which is 3. 0 minus 2, which is negative 2. So 3 over negative 2 is negative 1.5. Plugging negative 1 in, we get 2 on top. And plugging negative 1 in, we get negative 3 on the bottom. So again, that's going to be 2 over negative 3. So negative 2/3. So let's go ahead and graph those points. So going 1, negative 4. So 1, negative 4. 0, negative 1.5. And negative 1, negative 2/3. Okay? Now, this is new, different from what I went over in class. The horizontal asymptote is going to be the, notice that the degree of the numerator is 1. The degree of the denominator is also 1. When these are equal, you get the horizontal asymptote by taking the leading coefficient divided by the leading coefficient. So to get the horizontal asymptote, it'd be y equals 1 over 1. So y equals 1. So we're going to draw our horizontal asymptote here. And we can now draw in our graph along the asymptote, through the points, along the other asymptote. Okay, other side. Plugging in 3. So we have 6 on top, 1 on the bottom. Plugging 4 in, we have 7 on top. 4 minus 2 is 2. So 7/2, or 3.5. Plugging 5 in, we have 8 on the top. 5 minus 2 is 3, 8/3. Which is going to be 2, 3 goes in 8, 6, 7, 8, 2/3. So 2.6 repeating. So plotting those points. 3, 6, 3, 6, 4, 3.5, and 5, 2.6. And go along the vertical asymptote through those points and along the horizontal. All by hand, no need for a calculator. Now when writing the domain, I'm going to show you two methods. First method is interval notation. So interval notation, we would have negative infinity on the left to our vertical asymptote, which is 2. Use a parentheses, it does not touch 2. It goes up to 2, close to 2. Union, and then starts off at 2, but not including 2, so we use a parentheses to positive infinity. Okay? Inequality notation, well, so that was interval. If you want to use inequality notation, you could just say that x cannot be 2. So x would be x is an element of all real numbers such that x cannot be 2. Or some books and some authors just put down x cannot be 2 with the assumption that all other numbers work. So I'm fine with either method. Okay, let's look at number 2. So, first things first, always look for your vertical asymptote first. So we're going to set the denominator equal to 0. So we have a vertical asymptote at -2. I'm going a little bit quicker now. I only want to spend extra time on the new stuff. Okay, so this is where it's going to break up. So we're going to go -1, 0, -1, -3, sorry, -1, -2, -3 going to the left. And I'm sorry, I messed it up again. I'm kind of in a rush. You know, lunch calls. Going to the left, -3, -4, -5. Going to the right, -1, 0, and 1. So let's plug these numbers in. So we're going to have 3 over -5 plus 2, which is -3. So 3 over -3, which is -1. Plugging in the -4, we're going to have 3 over -2, which is -1.5. So we're going to have 3 over -1, which is -3. So let's graph those points. -5, -1. And -4, -1.5. -3, -3. Now, the horizontal asymptote. Recall, up here, this is something you're going to have to study. When the degrees are the same, 1 equals 1, you put the leading coefficient over the leading coefficient. Well, in this case, the degree of the numerator is 0. The degree of the bottom is 1. When the degree of the numerator is less, because this would be x to the 0 power if I put in an x, less than the degree of the denominator, your horizontal asymptote will always be y equals 0. So if you think about it, as x gets bigger, this number gets smaller. But it will never get to 0. It will get really, really, really small, but it will never get to 0. So we have an horizontal asymptote at y equals 0. You notice you can't see it very well, so I put a dash on both sides, so that way I know there's a horizontal asymptote there. So along the asymptote, boom. Okay, plugging -1 in. So we got 3, 0. So 0 plus 2 is 2. 3 over 2 is 1.5. 1 plus 2 is 3. 3 over 3 is 1. So at -1, we're at 3. At 0, we're at 1.5. And at 1, we are at 1. Domain, I'm going to go ahead and just do it the easy way. X cannot be -2. The assumption here is that all other numbers work. This is the only one that's excluded from the domain. All right. Let's look at another one. Running out of time. So here's what I want to highlight here is that the degree of the numerator is greater than the degree of the denominator. Okay, so that means that for the horizontal asymptote, there is none. None. Let's go back over here. Let's review it one more time. When the degrees are the same, when they're equal, then the horizontal asymptote is the leading coefficient on that variable divided by the other one. So 1 divided by 1 is 1. Okay. When the degree of the numerator is less than the degree of the denominator, it's going to be y equals 0. When the degree of the numerator is greater than the degree of the denominator, it is none. There is not a horizontal asymptote. So, I'm going to go ahead and let you do this one. Stop the video. Try to do this one by hand without a calculator. And we'll save number 4 for another time. Okay? See you guys in class tomorrow.